Resistors come in several sizes, and we have the capability of measuring resistances with a Beckman meter, with a Maztec meter, with a Syntec meter. These are all multimeters. They are not auto-ranging. We have a Fluke multimeter, which is auto-ranging. We have a Maztec 120 volt meter, which is also auto-ranging. And we have a Keithley multimeter, which is not auto-ranging. And we also have ELVIS, which is auto-ranging. ELVIS requires a computer. To measure a resistance, we must remove it from the circuit. It must not have any current or voltage attached to it. Here the resistor is completely removed from the circuit, and we're going to connect this probe to each of those multimeters. Now, the colors on the resistor indicate the size of the resistor in ohms. The colors are blue, gray, red, and silver, and they indicate the resistance size. Blue means 6, gray means 8, red means 2, silver means plus and minus 10%. Because this is a 4-color band resistor, the first two numbers, the 6 and the 8, are the size of the resistor, 68, times the third number, which is times 10 to the 2 power, that's 100, and the fourth number is the tolerance, 10%. Silver means 10%. So when we calculate the size of this resistor, it's 68 times 10 to the 2, or 6,800, or 6.8 K, plus or minus 10%. So any resistance between 7480 ohms and 6120 ohms would be in spec. Using the Beckman to measure this resistance, power on, and then on the resistance scale, turn it to the lowest possible setting, which is the 20K scale, and so this reading is 6.92 K ohms. With the Maztec battery-operated meter, we see ohms here. Black usually goes into the common. We turn this to the ohm scale, which is any value there. This is not auto-ranging. So again, we turn until we get the lowest possible reading. So that's too low. So we move up one, and that's the best measurement. 6.9, but we have to know that that's 6.9 K ohms. The Syntec meter works the same way, similar. We turn it on, insert the common connection, then the ohms connection, and then again turn it to the lowest possible ohms reading. That is too low. So one higher than that will allow us to read the measured resistance of the resistor. Now the fluke is auto-ranging. Black to the common, red to the ohms input. Turn this to ohms, and it reads directly the measured resistance of the resistor. It's auto-ranging. I don't have to select the scale. The Maztec 120 volt multimeter is similar. Black into common, red into the ohms connector. Turn this to ohms. It's also auto-ranging, and there is the measured resistance in K ohms, 6.91 K ohms. The Keithley multimeter is a little different. Still has the two input jacks. We turn it on. We select ohms, and then we have to select the lowest scale possible. That's too low. So we move up one higher, and there's the Keithley measurement of resistance of this resistor. Using ELVIS to measure resistance is a little bit more involved. Let's do this in the right order. I've moved to the top side so we can see it a little better. ELVIS requires 120 volt connection to the power supply here, which supplies the voltage to the ELVIS board. The USB cable connects to the computer. The input to the ELVIS board is here at, see the volt, ohms, and the common. So we connect our resistor just like we did in the multimeters. That goes into the ohms position, the ohms socket, and this goes into the common. This has to be on, and this has to be on. The LEDs indicate when it's on. Now on the computer, we start the NI ELVIS instrument launcher. We click on digital multimeter. It starts. We select the ohms scale. The picture shows how to connect the resistor to the ELVIS board. Then we click on run. It's auto-ranging, and there's the measured resistance with quite a few significant figures. And then we connect stop to make it quit. Oh, while it's running, it's repeatedly making the measurement over and over and over again. When we click on stop, it stops making the measurement.